The last in a series of 5 webinars funded by the Education and Training Foundation on aspects of design and delivery of study programs for learners with special educational needs and disabilities. My name is Zoe Hyde and I work for an FE college in Hertfordshire and teach students with moderate learning difficulties who range in ability from pre-entry to level 2. I will be talking to you about effective techniques for developing math skills, confidence and engagement. If you have any questions along the way, please type them into the question box on the right-hand side of your screen, and I will do my best to answer as many as I can at the end of the presentation. I will also be sharing my email address, so if you think of something in the next few days, please feel free to contact me. The presentation has been split into 4 sections. Firstly, I will be telling you a little bit about current practices in primary education and research. Secondly, I will show you some examples of how you can use manipulative or physical resources in class. Then I will share some techniques for problem solving and ways to question effectively. And finally, I will summarise and answer any questions. Welcome. This presentation will provide you with practical ideas for encouraging learners to engage with maths at their own level and decode word problems. I would like to emphasise that the techniques I'm going to show you can be used for any level, from entry 1 to GCSE and beyond. I have tried to include examples from a range of levels to illustrate this scope for adaptation if you can think creatively. The aims for today are to provide you with a short summary of the research evidence that supports the approaches discussed today. I felt that looking at research evidence was important to demonstrate that there is a sound basis for what I will be talking about. I will outline how to encourage mastery for deeper mathematical understanding. Mastery is the current trend within primary maths teaching. And rather than asking children to use larger numbers as a way to increase complexity, the idea is to deepen their understanding using the numbers they are currently working with. The entry levels and to a degree level 1 sit within the primary school syllabus, which is why I look to current primary practices to develop my own teaching skills. I will also give you some background on what prompted the mastery approach. The third objective for today is to discuss ways of helping students solve mathematical word problems. From my experience, I have found that students not only have to work on their mathematical skills, but also on their ability to problem solve. Our first section is about practice in primary mathematics and its corresponding research. I'm going to start with a bit of background to what is called the mastery approach, so you can understand what prompted the changes. In 2012, PISA data showed the UK was ranked 26 for mathematics. PISA tests are administered by the OECD, which stands for Organisation for Economic Cooperation and Development, and there are 72 countries in the organisation, so we came 26th out of 72. This prompted a redesign of the national curriculum in 2014 to reflect the principles found in high-performing countries like China, Japan, Singapore and Finland. This collection of principles is termed the mastery approach, where students develop a deep understanding of maths at each stage. By 2015, the UK was 27th out of 72. Unfortunately, we had slipped 1 place, but it will obviously take time for new approaches to take effect and be picked up by this kind of data. One country that particularly influenced those who set the new curriculum was Singapore, and I will now talk a little about how they developed their techniques. In the 1970s, Singapore were in a similar position to the UK on the PISA tables and started investigating why this was. They discovered that students had been trained to spot trigger words in word problems which linked to an operator. Now, I have run activities using trigger words myself with my students in the past. I'm going to explain this further in the next slide to make it clear what I mean by trigger words and operators. The problem is that the trigger word doesn't always match to the operator you have taught, in which case the whole strategy falls down. They also found that students had learned procedures by rote with very little understanding, and this relied heavily on their memory. From my experience, students with a learning difficulty may struggle with retaining information, so a strategy that relies on memory isn't advisable. In Singapore, they decided to develop techniques to help students work out problems instead. One method they developed is called bar modelling, or the Singapore bar method, and I will talk about this more in the next session of the presentation. So a little bit more about trigger words and operators. The term operator refers to the mathematical functions add, take away, times and divide. Trigger words are words that suggest or trigger an operator. This image is an extract from a worksheet I previously used, and I have a similar one for times and divide. We would cut the words out and students would sort them into different piles, one for add, one for take away. If we focus on the word more, I always thought that this should be put in the adding pile. But if we now look at a couple of examples using the word more, you will see that adding isn't always the correct thing to do. So if Avni had 5 pens and bought 3 more, we would need to add 5 and 3 to find out how many she has altogether. But if Jackie has 5 pens and Raja has 3 pens, to find out how many more Jackie has, the natural thing to do would be to take away, which results in us needing to complete 2 different number sentences to answer the 2 questions. We will now look at 2 pieces of research evidence that have informed current practice. The first piece of research is by a gentleman called Richard Skemp, who described 2 types of understanding. The first type he termed instrumental understanding, which is learning procedures by rote. An example of this would be teaching children their times tables by chanting. They may be able to recite them, but not have any understanding of what multiplication is. Instrumental learning is certainly how I was taught for the most part. We would be shown a method, do 20 questions to practice the method, and then it was deemed that we knew what to do. So what's the alternative? Skemp described something he termed relational understanding, which is where students are able to understand the links and relationships between different areas of maths. An example of this would be teaching fractions, decimals, and percentages together, so students can spot the patterns and links between the 3 ways of expressing the same thing. Mastery methods develop this understanding. With the time constraints that I appreciate most of us face, it may not always be possible to teach in a way that develops relational understanding. Teaching for instrumental understanding is certainly far easier and quicker, and in practice, if an assessment is fast approaching, you may need to resort to a talk and chalk method. I would say a combination of the 2 is probably the ideal, both for the student and us as teachers. The second piece of relevant evidence is quite old, but one that I think is really effective. Bruner identified 3 stages of cognitive representation. So he said that we have a concrete or a physical experience, which we then convert to a pictorial representation, and finally to an abstract concept. For the purposes of this presentation, I have kept the maths at quite a low level, but what I would like you to focus on is the idea of moving students through different ways of expressing the same idea. I use this to support students to work out what sum is needed to solve a problem. So in practice, this would be preceded by a word problem. If you had a question, for example, I had 4 screwdrivers and I buy 2 more, this is what could be used to represent the question in the concrete. This particular student has chosen to use 2 different colours of multi-link cubes. It is then converted to a pictorial representation or a diagram. As I have said on the slide, there is no right and wrong way to do these stages. The important thing is that it must be meaningful for the student, which is why I always provide a choice of physical resources. The final stage is to translate this into abstract symbols or a number sentence. As I hope you can see, this makes the link between a question and its corresponding number sentence very explicit. It is this stage in which the students I work with need the most support. I tend to find students are more comfortable moving from the concrete to the pictorial to the abstract. But for your higher level students, you could ask them to move from the abstract back to the concrete. I found this quite interesting because you can identify where there are gaps in conceptual understanding, as well as deepening existing knowledge. You don't have to use all three of these representations. You could choose to just use two of them. If we now extend Bruner's idea of different representations, for those of you who teach higher level maths, the next slide gives you an idea of how this would look at GCSE. So in this example, there is no concrete representation, but we do have a pictorial representation in the form of a graph and the abstract in the form of the equations. This is an extract from a card matching game. You could use it as a recap, a starter activity, or revision game. Students have to match the equation in symbols to that in words to its corresponding graph and table of points. You could make it harder by leaving gaps. For example, you could leave out one or two of the values for fx in the table, or include totally blank cards that the students have to create for themselves. That brings us to the end of the first section. I'm now going to talk about how to incorporate manipulatives or physical resources into your lessons. So these are examples of what I use, but I would like to point out that these are resources that work with my particular student group, and I appreciate they would not be suitable for everyone. I don't teach within a curriculum area, so I choose to keep the resources very neutral. If you do teach within a particular curriculum area, you may like to choose something that is relevant to your subject. The idea is to have something physical to hand that students can manipulate. If we start with the top right, I put these resource boxes on every table, which has the effect of desensitizing students to the use of resources. I believe they can be used to deepen understanding for all levels of student and shouldn't be viewed as something that is only used for lower levels. Moving on to the top left image, you will see that I have a selection of items for students to use. There are base 10 blocks, cubes, bead strings. I have strips of paper that can be folded or cut up, counters and measuring tapes which can be used as number lines. The two smaller pictures show a set of 3D shapes which the students can manipulate and experience, rather than trying to learn about properties from 3D drawings. And the set of coloured blocks are called Cuisenaire rods. The Cuisenaire can be used for lots of different topics, and there are some really good YouTube videos on how to use them if it is something you would like to look at further. I try to keep my lessons as interactive as possible, so rather than death by worksheet, I use games. So various dice are always good to have, and I've also used spinners for students to choose a digit, for example, which is a bit more fun than just being given a sheet of pre-selected digits. You can set up a spinner template on Word and personalise them to include all sorts of things, and the plastic arrow in the middle can be bought quite cheaply from eBay. I always also have a mini whiteboard, pen and cloth available for each student, so they can try things out but be able to get rid of mistakes quickly and easily. This seems to encourage less confident students to have a go, far more than using a scrap of paper or a worksheet would, where mistakes are more difficult to cover up. I'm now going to show you a couple of examples of how to use Bruner's concrete pictorial abstract technique with these kinds of resources. So I have replicated this based on answers actually given by students for the purpose of this presentation. As I said before, there is no right and wrong way to do the concrete and pictorial. It is whatever works best for the student. In this question, the student has chosen to use two bowls to show the two different days in the question and fill each with cubes to represent the number of clients booked in on each day. They have then converted this to dashes and used an arrow to show the two numbers are put together, and the student was then supported to select add as the operator needed to complete the number sentence. In this question, the student has used multi-link cubes and initially joined them all together in a long line of 18. They then started breaking off 6 at a time to show how many steaks were cooked each day. The next step was to convert this to a diagram using dots and then be supported to link division to the concept of grouping, which is exactly what they have shown using the cubes. The next topic we will be looking at is bar modelling. So a little bit of the background to bar modelling. It is also known as the Singapore bar method. It's a more formal version of the concrete pictorial abstract approach, and it needs to be set up in a very structured way, therefore may not be suitable for all students. I feel there is more scope to extend this method to GCSE level questions than there is with Bruner's approach. It is used to support students in problem solving and is a way to reveal the mathematical structure within a problem. This is where I would use the Cuisenaire rods as a concrete resource, which can then be transferred to a diagram or picture if you like to think of it in those terms. Squared paper can be used to support students to set out the model neatly, which will give them the best chance possible of getting to the abstract representation. It bridges the gap between concrete mathematical experiences and abstract representations in the same way that Bruner's approach does. We will now look at some examples. So if I start giving the students or use some information. So at college, the morning animal care group have some students, and in the afternoon they are joined by some more. The first step is to choose 2 bars to represent the morning and afternoon groups. If you are including the concrete stage, Cuisenaire rods are really useful because students can physically move the bars together to get an idea of what is happening in the morning. I'll now reveal a little bit more information. So the morning group have 10 students and they are joined by 5 more in the afternoon. Once students have a bit more information, you can ask if anyone would like to change their bars. I would hope that they spot the morning group has more students and therefore needs to be represented by a longer bar. And we can now add this information to the model. So the actual question is, how many students do animal care altogether? So students are trying to work out this amount and need to calculate 10 plus 5. The second example is a bit more challenging. So we'll start off by giving some information. So Ben's ribbon is 4 times as long as Daisy's. And we set the model up by putting the 2 characters, if you like, in the question there and put our bars in. The key thing to remember when setting up a model like this is to make sure that Ben and Daisy's blocks or bars are left aligned underneath each other. So Daisy's ribbon is 50 centimetres long and therefore Daisy's block represents 50 centimetres. So each of the 4 blocks that make up Ben's ribbon must also be 50. So we now get to the question, how long is Ben's ribbon? Lower level students may solve this using repeated addition and higher level may go straight to multiplication, but you can certainly have a conversation about the link between the 2 to support students to understand the concept of multiplication. The final thing I like to do when teaching students bar modelling is to ask them what other questions they can think of that relate to this model. For example, you could ask, how much more ribbon does Ben have? How much ribbon would Ben have to give to Daisy so they both have the same? Or what fraction of Ben's ribbon does Daisy have? Doing this allows you to talk about different areas of maths using just one question, so less work for you. I've used this with students who I would not have expected to be able to solve a question of this complexity. But the fact this is so visual has allowed them to see the answer, or at least see how they would get to it. The last example is similar to the previous one, but I wanted to expand on my point about covering multiple areas of maths from just one model. So if Isabel read 15 books, and that is 5 times as many books as Amber, let's set up our model. So we have Isabel and Amber. We can put our blocks in to represent the two. And we know that this amount is 15. So what questions could you ask? These are a selection of responses from groups I have worked with. I'd like to draw your attention to the breadth of the questions, from the most obvious, so how many books did Amber read, to the more complex, involving percentage and ratio. So this is obviously has scope for dealing with very mixed ability groups. The third section will provide you with some ideas to help students problem solve. And I will also talk about effective questioning. So, open or closed questions. There is often a misconception amongst students that maths is only about getting to one answer in one way. In practice, there is often more than one way to work out an answer. If you can ask more open questions, you can encourage dialogue that will help students with their analytical and reasoning skills. To explain what I mean more fully, we are now going to break to watch a video. I will send you a link which should appear in the window to the right-hand side of your screen. If you have your control panel minimized, you can expand it using the orange arrow in the top right-hand corner. If you have any problems opening the link, please search "Ever wonder what they would notice Annie Fetter" in YouTube and select the first result. The webinar will resume in 6 minutes. Pick up on a few points from the video. Effective questioning prompts creative thinking, which has a knock-on effect to problem solving. The use of "what do you notice" can be used at any level to provide opportunities to spot links between different areas of maths, which comes back to Skemp's idea of relational understanding. I am always surprised at the breadth of topics that come up, and every student, regardless of ability, can be exposed to those conversations. It is an example of a low threshold, high ceiling task, which means that although the entry point is quite low, the topic is only limited by the student's own ability. These sorts of tasks are particularly useful if you teach mixed ability groups. You may like to use one as a startup exercise to get students thinking before they split off and do more specific work that is tailored to the level they are working at. The way Annie Fetter suggests that we question helps engage less confident students because everyone is able to contribute something. It also encourages conversation and peer support. I have found that peers can sometimes explain things in a way I would not have thought of, which not only helps the student who is stuck, but also gives the person helping a sense of achievement. I will now talk through an example of the use of the question, "What do you notice?" As I have mentioned at the beginning of the presentation, I do not work within a curriculum area, so I have kept this example very neutral. I have used this as a warm-up, and the sorts of questions students have come up with are as followed. You will see the range of topics covered at even what I consider to be the lower entry levels, from simply noticing the colours to imagining the image as a 3D shape. Here are some examples of higher level responses. So again, there is a breadth of topics covered, from fractions to ratio and probability. My only note of caution would be that conversations can often go off at a tangent to the one you had intended. So at some point you may want to summarise and then steer the focus onto the topic of the lesson. So how can we help students to problem solve? In my experience, there are three issues. The ability to actually read the problem, the ability to then understand the language, and the ability to link the language to a mathematical concept. We've dealt with ways to link language to mathematical concept when we looked at the concrete pictorial abstract approach and bar modelling. But how can we support students to access word problems more effectively and confidently? I use 4 techniques, but I will elaborate on 3 of them. I'd like to emphasise that these techniques can be used for any level, Entry 1 to GCSE and beyond. One thing I do is to take the need for a solution away by simply removing the question temporarily. This forces the students to think about what they are being told in the scenario. It also removes any anxiety over getting to a solution quickly. I find that as soon as they see a question mark, some students find the numbers and start guessing at what to do with them with very little thought, and not giving them a question stops this. I will now talk about the remaining 3 in more depth. Technique 1 involves writing the steps like instructions to solve a problem, but not actually following them. This is an extract from an Entry 2 City and Guilds paper. The left-hand image shows the task and the right-hand image is the corresponding information pack. This task is about choosing food for a party. I would usually put students into small groups and provide them with large sheets of paper that will take their instructions and eventual answers. They often come up with slightly different instructions, which is great because we can then compare procedures and think about whose is the most effective or quickest or easiest to understand. This way, students get exposure to a wider range of strategies to reach the answer than if I just told them how to do it. If you can keep this question in mind, we will now look at an example of a student's answer. This is only one way of solving the task. When I have used this technique, I ask the students to just say, "work out," rather than including instructions on how to work it out. Many of my students work out the maths pictorially, but I personally would go straight to the abstract. By using the words "work out," it enables choice and a variety of ways to be considered. This gives students a way to get to the maths, but does not support the maths itself. As calculators are allowed in the assessment, and in real life, students would have access to calculators on their phone. In my opinion, it is a better use of time to support students to improve problem-solving techniques than to work on formal written methods. At this stage, students would then swap their steps with another group, and the other group would follow the steps to solve the problem. They would then give feedback to the group who wrote the steps originally as to how easy they were to follow, or if there was a different, easier way to do it. The second technique is about writing questions from a given set of information. This is an extract from an Entry 2 City and Guilds functional numeracy paper, which I provide to the students and ask them to write their own questions about it. These are some examples of possible questions the students have written, which you will notice vary somewhat in complexity. This technique can be used with mixed ability groups, as students will naturally think of questions at their own level. Only questions they know the answer to are allowed. You may have spotted that there are 3 narrowest bags. If I need to question students to scaffold or to prompt thinking, I usually throw in a wobbler or 2 just to get the students talking and to encourage them to justify their answers. I would set them up in small groups to write the questions and then swap questions between the groups so they actually answer another group's questions. The last technique I use is to ask the students to order a pre-prepared set of steps. This is an extract from a Level 1 City and Guilds paper. You, as the teacher, will need to prepare the steps, which you can then ask the students to order. I always do this in small groups because it gives students the chance to explain their thinking if there are any disagreements over ordering, and they wouldn't be able to do this if it was done individually. This technique encourages logical thinking, and you can always ask if there are any other ways to solve the problem, which will open up the possibility of getting to the same answer in a more effective or easier way for the student. This nearly brings us to the end of the presentation. I will now summarise and answer any questions that may have come through. So effective teaching will make the link between practical experience and maths symbols really obvious. That's the concrete pictorial abstract approach that Bruna suggested. It will help students to decode word problems. Bar modelling is very good for that. Teachers will ask open-ended questions and ask why to encourage reasoning and deeper understanding. They will use low threshold, high ceiling tasks with mixed ability groups and encourage analytical skills by asking, what do you notice? They will practice problem solving by taking away the need for a solution so students can focus on what is actually happening in the question. Here are some references I have used throughout the presentation if you would like to read more about Skemp and Bruner's theory. I would also recommend the books by Jo Boaler. They are very easy to read and really interesting. If you would like more examples of bar modelling, take a look at Thinking Blocks, and the link is there at the bottom of the screen. There is also a junior version of Thinking Blocks, which will give you some lower level examples, but you may need to make them more age appropriate to use with older students. I'm now going to review the questions, and I will come back to you very shortly with some answers. Hello everyone. Just to confirm, we will be sending out a copy of the webinar to you all. So you will get copies of the slides and you will be able to view it again. A question I've had relates to one of my examples on the bar modelling. So I'm just going to go back to that slide. Yeah, I believe it is this one. So somebody has asked, how do students know you are dealing in multiples of 5 on this question? Do they work it out or do I tell them? what I would do, if a student couldn't see that each of these individual yellow blocks represents 3, I would draw this as a much larger diagram on a piece of paper and actually get 15 cubes or counters and get them to share them equally into the blocks. And hopefully then they would discover that each block represents 3. But I would get them to do it practically. I wouldn't tell them. I could then talk to them about, oh, well, look, we've got 5 blocks here. Each block is 3. So you could either do a repeated addition or then say, well, how many lots of 3 have you got? 5 lots of 3. And then explain that that could be 5 times 3 written in the abstract. Does anyone else have any questions?
There's a question from Ali O'Brien about low threshold, high ceiling activities and what range of abilities have you worked with in one group?
Right, I've got a question about the low threshold, high ceiling activities and how many levels I've dealt with in one group. Typically, my groups can be entry 2 to level 1. So I would start off as a whole group with one of these sorts of activities and go from there. So yeah, you're talking E2, E3. You sort of over 3 to 4 levels I've used them with. I've got a question about spiral curriculum. I haven't experimented with that, but I will certainly go and look it up now I've heard about it and that it's worked for you. So thank you. Okay, if there are no more. Oh, hang on. Okay, so why does the bar modelling have to be orientated to the left or to the right? The reason I would, and if you can see my screen, the reason I would make sure this is aligned, so squared paper is really useful, is because the idea is that they get this sense that if you're doing a question about more than, so if I said to you, how many more books has Isabel read compared to Amber? The more than space would be this space here, and I would actually draw an arrow and we would talk about, well, how can we calculate this space here then, if this is the more than space? And if you don't align them to the left, it just makes the model look sort of odd, and then the more than space doesn't make sense. So the only drawback with this type of modelling or this technique is that, to my mind, you do have to be quite neat with it, and not all students are able to do that for various reasons. So that's why it has to be aligned to the left. I've got a question that says, how do I find out about more of these? I'm assuming you're thinking of the bar modelling, so some more examples of bar modelling. The link to Thinking Blocks, which is on that last slide, if you Google Thinking Blocks, it should pick it up anyway. There are some really nice examples on there, and like I mentioned, there is a junior version of Thinking Blocks, but it will just give you an idea of how bar modelling works, even if you decide to go away and actually write your own questions or change the questions or simplify the questions. it will give you an idea of how it all works. So I would recommend the Thinking Blocks activity or the Thinking Blocks online games. Okay, sorry, I apologise. The question, how do I find out about more of these, was more of the webinars. I believe that if you go to the Education Training Foundation website, you should be able to find out about more courses or webinars that they are putting on. Okay, so if there's no more questions, I think that brings the presentation to a close. As I said, it will be available to you and it will be sent to you to review, and please feel free to contact me if you have any other questions. Thank you.